Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. My name is Muhammad Shafi bin Ismail S.H.A.F. So today I would like to present our math group project. Our course name is BBP10603. So we choose the question. The question is structural engineering project. It is for calculating steel beam length. We going to the next section. Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Syakir bin Ismail Shah. Assalamualaikum
Assalamualaikum
warahmatullahi
warahmatullahi
wabarakatuh. My name
wabarakatuh.
is Ismail
My
Shah.
name is
Saya
Muhammad Haziq bin Muhammad Rizal, and my metric number is
Assalamualaikum warahmatullahi wabarakatuh. My name is
CB2400358.
Muhammad Syakir bin Ismail Shah. This is for introduction. Introduction is a beam is a structural element that primarily resists loads applied laterally across the beam axis. This is an element designed to carry a load pushing parallel to its axis would be a strut or column. So, its mode of deflection is primarily by bending as loads produce reaction force at the beam's support points and internal bending moments, shear, stresses, strains and deflections. Beams are characterized by their manner of support, profile shape of cross-section, equilibrium conditions, length and materials. So, the beams are traditionally descriptions of building or civil engineering structural elements where the beams are horizontal and carry vertical loads. So, any structural element in any orientation that primarily resists loads applied laterally across the element axis is a beam. I would like to pass these slides to the next presenter. Thank you.
First, we go to the problem statement. This project involved the determining the approach leg of the type of steel beam A, B, and C request to support the structural load of a new building design. Each beam type, pressure, and listed load bearing capacity, and their combined use must meet to the load requirement specific for different support location. Second, we go to objective. First, the first thing is ensuring the load capacity of at support location 1 meets or exceeded 10,000 kilonewton. And number two, ensuring the load capacity at support location 2 meets or exceeded 8,000 kilonewton. And number three, ensuring the low capacity at support location 3 means exceeded 6,000 kilonewton, including distributing the required layer of beam A, B, and C to achieve the above low capacity.
So for the methodology, I will talk about the process and method used to calculate the length of beams A, B, and C to fulfill the minimum load requirements are presented here. The steps are outlined below. So the first one is for the startup procedure. So prepare all necessary tools such as calculator, pen and paper for manual calculation or software like Excel for automated. Note the given beam capacities and load requirement. Beam A 2000, kilonewton per meter, beam B 1500 kilonewton per meter, and beam C 1000 kilonewton per meter. Load requirements location 1 is 10,000 kilonewton. For location 2 is 8,000 kilonewton, and for the location 3 is 6,000 kilonewton. And then formulate equation based on the load requirements at each location. So next step is use trial and error or mathematical optimization techniques to determine the length of the beams LA, LB, and LC that specify all three equations. Next, ensure the solution is optimized by minimizing the total length of beams while still meeting the load requirements. Adjust calculation if necessary, and then verify the result by substituting the values of LA, LB, and LC into the equation to confirm they meet or exceed the requirement load. And for the lastly is shutdown procedure. Record the final beam length, clean up the workspace, save all calculation and tools. For the next slide is analysis and discussion. To determine the necessary length of each beam type A, B, C to meet or exceed the total load requirements at each location, we can follow these steps. The image provides information about load requirements for three support, location, and the capacities of three beam types A, B, and C per unit length. So for the first one is the load requirements for the structure are support location 1, a minimum load capacity of 10,000 kilonewton. Support location 2, a minimum load capacity of 8,000 kilonewton. And for the location 3, a minimum load capacity of 6,000 kilonewton. And for the second one is the load bearing capacities per unit length of the steel beams are beam A 2000 kilonewton per meter, beam B 1500 kilonewton per meter, and beam C 1000 kilonewton per meter. That's it for me. Bye.
Okay, let's go to the last slide is conclusion. The required length for each type of beam A, B, and C to meet the minimum load requirements at specified for location. It includes the load requirement for three support location and the load capacity per unit leg for each type of beam. At support location 1, the minimum load capacity required is 10,000 kilonewtons. At support location 2, it is 8,000 kilonewtons, and at support location 3 it is 6,000 kilonewtons. The beam characteristic based on load capacity per unit leg are as follow. Beam A has a load capacity of 2,000 kilonewtons. Beam B has a load capacity of 1,500 kilonewtons, and beam C has a load capacity of 1,000 kilonewtons. Beam legs required to meet specific load requirement. It includes the calculation for beam C or low capacity and summarize the necessary leg for three different beam type A, B, and C. For beam C, which has a minimum load requirement of 6,000 kilonewtons and a load capacity of 1,000 kilonewtons, the required leg is calculated to be 6 meter. The summary also include the necessary leg for beam A, which is 5 meter, and for beam B, which is approximately 5.33 meters. Calculation should state overall of the process to calculate all the variables needs to solve the problems.